Our talk today is going to be in two sections. So I'm going to start this webinar gently. I'm going to be introducing the concepts of complex interventions and components, and then Nikki's going to take you through the statistical methods. So specifically, I'm going to outline what complex interventions are and how standard meta-analysis approaches deal with complexity, before moving on to introduce network meta-analysis and then briefly touch on the principles of component network meta-analysis. Nikki is then going to pick up from there and explain the statistical and modelling possibilities before moving on to some worked examples. So, moving straight on, what are complex interventions? Well, I'm sure many of you have a pretty good idea already of what some complex interventions are, but it's possible that you might not be aware that the new Cochrane handbook has a whole chapter dedicated to complexity. And I thought it was interesting in that chapter to note that it speaks of intervention complexity rather than complex interventions. So the idea is that there isn't a dichotomy between simple and complex interventions, but rather a spectrum of complexity, and that all review authors, regardless of what our interventions or our treatments are going to need to consider some aspects of complexity. So even if we're doing a review of pharmaceutical interventions, we might still have to consider things like doses or titration in a drug review. So coming from that perspective where there is no such thing as a simple intervention, the handbook notes that there are three ways to understand intervention complexity. The first is the number of components in the intervention, and then the interactions between those intervention components, or interactions between the intervention and its context. And also then there's this final idea of the wider system in which that intervention is introduced. In specifying those aspects of intervention complexity, the handbook also references the UK Medical Research Council's 2008 definitions of complexity, which are really the most commonly cited definitions of complexity. So the MRC defines complexity as the number of interacting components within an experimental and control intervention, the number and difficulty of the behaviours that are required by those delivering or receiving the intervention, the number of groups or organisational levels targeted by an intervention, the number and variability of the outcomes, and the degree of flexibility or tailoring of the intervention permitted. Of those aspects, the ones that we're going to consider in this webinar are the number of interacting components within the experimental and control interventions. In a 2019 review of the methods of looking at systematic reviews and quantitative synthesis of complex interventions, Julian Higgins et al. Laid out the synthesis options that we have available if we are doing a review where we have intervention complexity. So firstly, they summarised that we could look at non-statistical approaches to summarising that evidence, such as things like harvest plots, bubble plots, and albatross plots. Then, of course, we have the option of using standard meta-analysis methods, which might also include meta-regression approaches. And then finally, Higgins et al. Identified these complex synthesis methods, such as network meta-analysis, multi-parameter evidence synthesis, and multivariate meta-analysis. Now, the reason I've listed those there is that it's worth noting that these more general methods, such as MPES and multivariate approaches, that they can also be utilised to address some of those other aspects of complexity that were described by the MRC guidelines, for example, the number and variability of outcomes. But because what we're going to focus on in this talk is network meta-analysis and the number of components and the potential interactions between those components, that's going to be the focus for the remainder of the session. The worked example we're going to be using throughout my section of the talk, but also for the beginning of Nikki's, is this subset of studies from a 2004 Cochrane review, which examined psychological therapies versus intervention as usual for reducing depressive symptoms post-coronary heart disease, so post-myocardial infarction. And this was a much wider review, but there were only 11 studies that reported the depression symptoms. So these studies, these 11 studies, were combined in a meta-analysis using a random effects inverse variance model, and the standardized mean difference is used as the summary effect measure. So looking at our meta-analysis and having a look at the pooled summary effect measure there, it would appear that relative to a treatment as usual comparator, psychological interventions were seemingly effective for reducing depressive symptoms post myocardial infarction. But of course, there are further questions that we might want to ask here, not least exploring the possible sources of this substantial between study heterogeneity. Which is really quite large, and such that if we constructed a very crude predictive interval here, it would suggest that in some future study, psychological interventions could be consistent with an actual increase in depressive symptoms. So, of course, when we are conducting a standard meta-analysis, we're required to make some decisions about how we're going to analyse the interventions along a spectrum of what's been called lumping and splitting. So, to maximise the number of studies that were included in that meta-analysis that was just shown, clearly a decision was made in advance that they were going to lump all of those potentially different types of psychological intervention together to form a single active comparator for the analysis. Of course, what this means in practice is that there's a whole hodgepodge, a whole melange of interventions made up of different ingredients based on different schools of psychology, which were assumed to be combinable in order to conduct that meta-analysis. And so, of course, perhaps it's not at all surprising, and perhaps it's inevitable that we observed such a high degree of heterogeneity in that analysis. Now, that's not to say that pairwise meta-analysis with a lumped intervention comparator doesn't have its place. It does. And it comes down to the purpose of the review, the systematic review that we're conducting. So if the purpose of our review is to answer an in-principle research question, such as do psychological therapies as a whole, on average, reduce depression after coronary heart disease, then yes, absolutely, a pairwise meta-analysis does have a role to play. However, if the purpose of the review is to investigate which type of psychological intervention is effective, or which intervention characteristics are effective, then perhaps splitting those interventions, dismantling them, may be the more helpful approach. Because from a decision-making perspective, whether that's a governmental body, a health service, or an individual clinician, it's more helpful to them to be able to offer a specific psychological intervention and not a hypothetical or an average intervention. So in a pairwise framework, as I'm sure everybody already knows, we can investigate that splitting question looking at subgroup analyses or even using meta-regression. So essentially what we're doing, as identified here by Guys et al. And Melendez-Torres et al., we're looking for a key characteristic of an intervention, and then we're using that to group them together in analysis. So for example, in psychological interventions, a key characteristic might be how the intervention was delivered. Was it delivered as a group psychological intervention, individual, self-help, as examples? Or we might also think about the approach to therapy which was taken. Was the therapy a cognitive behavioural therapy? Was it a behavioural therapy or counselling, for example? Now, Melendez-Torres considers these as clinically meaningful units. So what we're thinking about here is at the intervention level of analysis and defining them in a clinically meaningful way. So out of interest, but very quickly, if we think about a subgroup analysis here on the basis of how the intervention was delivered, whether it was individual, group, or mixed, it might appear, giving you a bit of time to digest the slide, that it doesn't, grouping my studies by this characteristic doesn't really seem to have explained that degree of heterogeneity. But if we look at it by intervention type, whether it was CBT, BT, or counselling, this grouping might help to explain some of that heterogeneity, although it is pretty tenuous. I absolutely agree if anybody's looking at that and questioning it. So obviously one of the key issues that we have here in our subgroup analysis is that I only had 11 studies overall in my meta-analysis, and our ability to conduct a meaningful subgroup analysis here is restricted. In that first subgroup, we have 3 studies, for example. However, if we move on to start considering intervention complexity from within a network meta-analysis framework, we have greater flexibility and the potential to make better use of that limited data. So as you probably all know, a network meta-analysis allows the simultaneous comparison of multiple interventions to be combined in a single analysis. And when we are using our RCT evidence, it enables us to preserve the original randomized nature of that evidence. As long as my aforementioned studies, those 11 studies, form a connected network, here denoted by these solid black lines between my CBT node and my treatment as usual node, for example, as long as those studies form a connected network, they can be analysed in a network meta-analysis. Crucially, including all of that evidence in this single analysis also gives us the potential for effect estimates to be more precise and more robust, since they're based on more evidence. But it might also offer us the potential to, the greater potential to explore the heterogeneity. And again, as I'm sure everybody knows, combining our evidence in a network meta-analysis also allows us to make indirect comparisons where we lack head-to-head direct evidence, say here of CBT versus behavioural therapy. So in that example, clearly we've got direct head-to-head evidence relative to some treatment as usual comparator, but it may be of greater interest to those decision makers we mentioned to have estimates of the comparative effectiveness of the active interventions, CBT versus BT, which we didn't get from those subgroup analyses that I showed you a couple of slides ago. So those are it's very very quick whistle-stop tour, a refresher probably of the concepts of network meta-analysis. But for completeness, let's just have a look at the results from that clinically meaningful unit intervention level analysis, again using a random effects model. So the table that you can see now reports the comparison where the active or the experimental treatment is listed first and the control intervention is listed second, such that VT versus treatment as usual, where our standardized mean difference is negative, that is favoring the first treatment, the active treatment. So in a network meta-analysis, we're also able to produce treatment rankings, although increasingly it has been noted that we need to be cautious when we're interpreting treatment rankings from a network meta-analysis. And this is actually a good example of why we need to be cautious in interpreting treatment rankings. Because if we see here, it would appear that behavioural therapy has been ranked as the first treatment, the best treatment. We can see here that the credible intervals are indicative of such uncertainty across all of these treatments that it would be, I think, inappropriate to draw any conclusions about there being a best treatment for reducing depressive symptoms post-MI. So, getting back to the issue of complexity, over my last few slides, I'm now just going to introduce some of the concepts behind what we mean when we're talking about components of complex interventions. And then I will, if there are any points of clarification, I'm happy to take a couple of questions before handing over to Nikki, who will then go straight into showing you how the component network meta-analysis works. So it's often said that complex interventions are more than the sum of their parts. And it's these parts that we're considering as components of the intervention. So we should also actually note that when we talk about components, we're talking about both the content, well, potentially talking about both the content of the intervention itself and the process of delivering it. And for many interventions, those two things, the content and the process, may actually be inseparable. Components have been described as the active ingredients, the processes, the intervention techniques, or the elements of an intervention that have the potential to causally influence outcomes. The literature on components also refers to some as being key or core components, in that they're considered the main drivers behind an intervention effect. And such components are considered directly related to an intervention theory, a theory of change, which proposes the mechanisms by which an intervention works. So in a systematic review context, in this talk, we've already alluded to the fact that dismantling interventions by some key characteristic, as we did for the subgroup analyses, may be useful when we're exploring heterogeneity. So there's a utility within the systematic review itself. But dismantling interventions into their constituent parts can also be useful for recommendations arising from a review and for future implementation of interventions. For example, if we thinking about intervention components can help us to understand how the intervention works. It can help us to identify the core drivers of an intervention effect, and then we can start to think about which intervention components are essential for intervention effectiveness. This can allow decision makers to adapt or to modify interventions in practice without compromising their effectiveness, and can also help us in the optimization of interventions for future studies. So rather than using that whole clinically meaningful unit intervention level in our network meta-analysis, what we're thinking about in a component network meta-analysis is, in effect, using the components themselves as the unit of analysis. Or if you like, you can imagine them as the nodes in that network plot rather than the whole intervention. And in this way, a components network meta-analysis has been likened by Melendez-Torres to being like a factorial trial. So if we can think of a standard intervention level network meta-analysis as being analogous to a huge multi-arm trial, then Melendez-Torres has suggested that we can see a component network meta-analysis as a set of dismantling trials, which are comparing different combinations of components against each other, which Nikki will demonstrate in her section of the talk. The hard part, believe it or not, is actually identifying the components. So ideally, it's desirable, it would be desirable to have the components of interventions pre-specified in advance in a protocol, and this would help us avoid data-driven decisions in our review process. Unfortunately, the state of development of the field is such that these off-the-shelf classifications of components or taxonomies of components may not exist, or actually they might not be relevant for the question that you're asking in your review. So to date, components are typically identified as part of the review process. For example, one often used method is this first one on this slide, and it's a qualitative technique known as the constant comparative method, which relies on the reviewer using the published papers or maybe treatment manuals in the case of psychological interventions, and using that reported information to identify the components. Other approaches have been used which rely a little bit on that inductive and iterative classification approach, but then also taking it to a consensus-led approach, such using methods like a Delphi approach. And then more recently is a project, the behaviour change project based at UCL in the UK, which is actually looking at using artificial intelligence and machine learning approaches to identifying the components. But what those first three approaches have in common, to a lesser or greater extent, is that they are relying on the published literature and for authors to have reported accurately and entirely what materials, resources, processes, etc. Were implemented. And this last approach by De Bruyne and colleagues suggests that relying on that published literature is probably problematic. The published literature is likely to be a poor source when we are identifying components. And whilst we might hope and anticipate that reporting guidelines such as the TIDIA checklist and the consort extension for social and psychological interventions can improve that going forward, we have to acknowledge that currently this is a limitation in identifying our components. That limitation notwithstanding, going back to our case study, we used that qualitative constant comparative approach to identify 5 key components from the published literature. These were educational, behavioural, cognitive, relaxation and supportive components, and they were used as the inputs into the network meta-analysis, which we can visualise as this network plot. So you can see that in practice that this network is quite sparsely connected. We can see that we have some interventions that had an educational component, some which had a behavioural component, some which had a cognitive component. We didn't have any which had this relaxation component on its own. And where you see in this plot, this plus sign between educational and behavioural approaches, what that indicates here is a combination of components. That intervention had both an educational and a behavioural component. But Nikki will talk about the types of models we can consider for component network meta-analysis in more detail. That's the end of my section. Are there any points of clarification anybody would like before we move on to Nikki's?
Thanks very much, Debbie. There's one question that's come here. The question is, using the level only report, so just using the trial level and typical reporting in trials, can we be confident of more or less often finding the richness of detailed description for an intervention complexity approach?
Well, I think, yeah, that's, you know, there are limitations. There's no doubt about that. So it's a perfect chance to do the limitations slide. So the limitations very much are around the reporting. But for the most part, we are relying on what has been reported. De Bruyne did find that when he and his team contacted authors, it's an incredible piece of work. They had an excellent response rate. So what they did was they used the behavioural change taxonomy, which was developed by Mickey et al., and asked authors to comment on. So they sent it to the authors and asked them to say which of these components were included in their in their intervention, and they had a fantastic response rate. Off the top of my head, I think it was 90% or something like that, of which they say that 2/3 of that response gave extra useful information on the ingredients of those interventions. So I think this work was only just published at the beginning of the year, and I think it's a really interesting approach, which could overcome some of the limitations of relying on the published literature.